Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're here to work on our tape head preamp, and this one is based off a YouTube video I saw. I'll put the link below. It's like Fox Bat or something. I'll put it up here, the name of the channel too. He did a modification of a Marantz 7 board. This little gold and black one. And it's the same folks that make my EAR board, but this is a different circuit. It uses three 12AX7s, and it also has a tube rectifier, which is a little different. But anyway, the key difference is this one uses the feedback loop to create the RIAA EQ, and so it can be fairly easily modified to do the IEC 15 IPS curve, which is what we're after. And I'm sure that you can figure out how to do the NAB and other curves with it, but I'm focusing on the IEC curve because that's the tapes that I have. They're 15 IPS and they're IEC. And so we fabbed up this fun chassis here. It's the same basic box that I use for my phono preamps. We did a little different. It's got the inputs here on the end, just like my normal one, but then I put the outputs and the RCA on the back, and it's going to sit on the shelf like this with the tape sitting here, or the tape deck sitting right here, and so the wires can go in. Probably going to be using a 5-to-1 step-up transformer, and we'll get into that when I show setting this thing up. Obviously, I don't know what this thing sounds like yet, and so don't build it until you see the final test video. But I know people want to see how to build stuff, and if I build it and then test it, then I got to take it back apart. So I'm going to show you how I built this thing. I did mod the board a little bit. It's made to work with a 6N2 or a 12AX7. And what they did was that they ran the heater traces to pins 4 and 5. And then if you're going to run the 6N2 tube, you have to use a 6.3 volt transformer, and then it's designed so you have to use a 12.6 volt transformer if you're going to use a 12AX7. Well, I wanted to use the same 269AXs that I use with my phono stages. I've got a bunch of them here, and this has 250 volts, and it also has 6.3 volts at 2 amps. So what I did is I tied pins 4 and 5 together and lifted pins 4, I believe it may be pin 5, but I lifted one of the pins so that only one side of that is getting the voltage, and that 4 and 5 are tied together. And then I put the other side of the 6.3 on pin 9, which is this little jumper wire right here, and that allows you to use 6.3 volts with a 12AX7. And I'll show that more close up here in a second. And then I went ahead and tied the filaments for the rectifier tube to the same traces that put the 6.3 volts in, so that everything's running off 6.3 volts. And to me, that really simplifies it. I've got no interest in playing with those other China, Russian tubes, whatever those things are. I'm going to be using probably 7025 tubes, which are a low noise version of a 12AX7 with a little less gain, and they sound really nice. So anyway, besides that, the only other real mods, and here's what the schematic looks like, and it has a 100K input resistor instead of a 47K to more lightly load the tape head. So it still uses the 6800 cap. I used a nice mica cap because I know they sound really good in my phono stage. And then the only other component, you get rid of everything else that's in there, and you put a 10K pot in series with this capacitor, and that gives you an adjustment on where the curve ends up. And it's basically for adjusting the high end. And he said 7.5K is a good starting point. I've got tapes that are the IEC curve, so I can dial this thing in, and once I get that dialed in, I'll tell you all exactly what the value is. May replace that pot with a resistor, but may just leave the pot in there. And I'll do a close-up here in a minute and show you what all this looks like. And I think it's going to be a pretty simple build. So let me show you the details. So this is the board that we're using to do our tape head preamp. And as you can see here, it says Marantz 7 phono RIAA. And we're using the same gain stage that is used for a phono preamp, but we're changing the EQ from RIAA to IEC 15 IPS to work with our tape deck. And it's pretty simple mod to do. And I'll show you the parts that get changed. And as you can see, board gets all populated. I bought the kit that came with the resistors and the diodes and the tube sockets, and it didn't come with any of the caps, either for the RIAA or these filter caps, because I wanted to use some nice Nikon filter caps and some higher quality caps in the other parts of the amp, the smaller PF type caps. And so I thought this was a good route to go, and it comes with, like I said, these tube sockets and stuff, so you don't have to go buy those. I actually ended up using some different tube sockets. The ones that came with were kind of cheap looking. They're the ones that come with the EAR 834 kit are actually pretty decent. These seem kind of cheap, and so I had these black guys, and so we ended up using those. This one seemed okay, the 7-pin one. So this is our rectifier tube. Here are the diodes that filter or convert to DC for the heaters, and that's what this section down here is for, filtering the DC for the heaters to try to keep the amp as quiet as possible. The rectifier tube is used for the B+, or the high voltage that goes to the plates of the tubes. So we've got kind of two different power supplies. It's kind of weird they have the power supply kind of all, mixed across the board. These are some of the caps for the filtering for the B+. It is nice they have the voltages marked on the boards, what they should measure. So when you're done with the preamp, you can measure these voltage points and make sure that you actually have the correct voltages, which is a nice feature. And what I'll probably do is semi-breadboard this. This is the transformer that I'm going to be using. It's a Hammond 269AX. And if you're in Europe, you'd need to use a 369 because it has the dual winding primary, so you can wire it for 120 volts or 240 or 230 or 110. All those other voltages are possible. This one is 115 volt, but it's also got a 125 volt tap, which is what I end up using on these. And you use the white and the black wire, and I just tape off the wires that I'm not using or heat shrink them off and leave them in the end bell, so I don't have the unused wires coming inside the amplifier. The other one we're not going to use is the center tap for the high voltage. So I just cut and put some heat shrink tubing on the gray wire and the red with the yellow stripe wire. So we're just pulling out the 250 volt. Those are the primaries, and these are our 6.3 volt secondaries. So good transformer. I've used a bunch of these. They run nice and cool. They're quiet, and it's a perfect size for using on these kind of preamps. The other thing I do for my chassis is I use these standoffs, and then I attach the LED like this on some little extra length of wire so that it can peek out through a hole in the top of the chassis for the power indicator. And then on the bottom, I've got my Mundorf coupling caps. Decided to go ahead and upgrade those. And then I'll talk about these jumper wires here in a minute. And then these are the 10K potentiometers. I got some small multi-turn ones so that the adjustment isn't so touchy. They're 10-turn multi-turn pots. And again, they're 10K. And you can see how they mount like that. And I'll show you on the other side how I wired those up. Yeah, I was pretty excited about this. I didn't really want to wait and do a step-by-step video. But before I put this thing in the chassis, I'll show you how I modified this thing. So again, for the majority of these parts, you just use whatever value is on the board. Some of the resistors that came with it were a little out of spec, and so I replaced them with some, nicer resistors that I had that were in spec, but a lot of them were fine. And so just measure them all before you put them in the board and make sure they're within spec. And then I put some audio grade caps here that would be on the cathode to make sure, it's cathode bypass, to make sure we had some nice caps there. Same here, these are audio grade caps. And then I used these mica caps for the 100 PF and the 22 PF that go on the first tube around it and as part of the feedback loop. The other thing that was changed is this resistor here sets the input impedance. Let me zoom in here. So this resistor and this resistor set the input impedance for the preamp. And the guy that I got this idea from, he suggested upping these from 47K to 100K. And so we did that, and that'll reduce the loading on the tape heads. Maybe one of those things where certain tape heads like a certain loading, and this is where you tweak that, is with this resistor right here. So the other parts that we changed, again, all this stuff stayed the same. The first thing that we changed was this cap here was originally a .01 UF cap, and it was made that small. It's working against a 330K grid leak resistor, and they did that to act as a rumble filter for older turntables. And even if I was building this for a turntable as an RIAA, I would increase this to at least a .15. We went to a .22 UF to make sure that we got really strong low frequency response. So that was for both of these, which would be this cap right here. Okay? So the next thing we changed was in the RIAA circuit. There was like a 680K resistor and a 47K and a 1K. You don't install any of those. Put a jumper wire from here to here, because here's this trace here is the feedback loop from the output, and it connects right here. You have one pin of that potentiometer connected here, and then you have the center pin and the other pin connected on those two. So the center pin and the other pin, which is the output, are tied together, and then this is which is the wiper and the output, and then this will be the input to the pot, and this allows you to adjust this potentiometer to get the ohms that we need. Starting point's about 7.5K, he said. And this trimmer trims the high frequency response. So then the signal comes here, goes up this jumper wire, over to this trace, comes over here. This is our 6800 PF mica cap that then comes down that trace, and that goes up to the first tube to complete the loop for the feedback circuit, which is our EQ for our tape head. So that's how you change this from RIAA to IEC 15 IPS. And in the guy's video, he shows the curves and how he tweaked this over a couple of videos. And he figured out that this simple little resistor cap is all you need to get the right curve for a tape head, which is awesome because to me, less parts the better. And otherwise, we still use this 0.1 UF cap here, and it's actually fine being this size because this cap is working against a 1 meg grid leak resistor on the next stage, and so it's got plenty of low frequency response. It's not going to roll it off. And then this is the output tube, or the final tube in the circuit, and then here is our output terminals. And then on this cap here, I also increased the value of this from 0.47 to a 1 UF. And the value of this cap will depend on the impedance of the amplifier that you're driving. And I'll put a link in the description to a great site that has a little calculator for calculating up what size capacitor you need to use to drive a certain input impedance without having any problems. So the last thing we modified, it was kind of a weird setup. They were trying to set this up where you could use either a 12AX7 or something like a 7025, which is what I'm going to use, which is a lower noise 12AX7, or you could use these China, Russian, I don't know who makes them exactly, the 6N2, which is a weird tube. And it's a 6.3 volt tube, but the volts go across pins 4 and 5, which are also the heater pins for a 12AX7, but on a 12AX7 that would be 12.6 volts. And it's the same problem you run into with like that Risong A10 versus an A12 when you want to convert it. And I guess you could use adapters. I know they make the 6N2 to 12AX7 adapters if you don't want to mess with this wiring, but I do think that it's better to just hardwire it for a 12AX7. And what I did was, and it might be kind of hard to see, let me see if I can get the right angle on this. So you can see here I've got a little jumper wire and I connected pin 4 to pin 5, and then I cut pin 5 here so that it's not connected to the board anymore. So these two pins are tied together with only pin 4 connected to the board. So then what I did on the other side, I connected where pin 5 was connected to pin 9, which is the center point of the two sides of the heater on a 12AX7, so that it's a 6.3 volt heater. And by doing that, it converts this board to putting 6.3 volts across the paralleled heaters of the 12AX7. And I hope that makes sense. If you look at the tube layout for a 12AX7, you can see here how the two heaters are paralleled if you connect pin 9 and then tie pins 4 and 5 together for the other side of the heater. It parallels the two heaters and makes it a 6.3 volt tube. And that's how I hardwired it to be like that. So finally then, the other thing that I did is I put a jumper wire from here to the filament of this rectifier tube, and then from here to the other filament of the rectifier tube, and then I can just put 6.3 volts here, and it will put 6.3 volts across the correct terminals on all three of the 12AX7s. And I did that pin 4 and 5 connect mod and the jumper. You can see I put the jumpers down on the other two tubes as well. And the way this board was made, pin 9 wasn't connected to anything. And so we're using pin 9 as the center tap and connecting pins 4 and 5 on the tube socket and then we're cutting off pin 5 where it would connect to the board. Hope that makes sense. And again, back here on this end, then we just put 6.3 volts across here, and then it says 260 volts to 275 volts. We're going to be putting 250 volts on there. That's going to be close enough, I'm sure. And then there we go. That was the mods that we did to this thing to make it work for me. So here's our little tape head preamp, and this should convert a NAB tape deck to a IEC 15 IPS EQ, which is what I need to play those new production high quality tapes on my 2-track deck. And then the final thing is this terminal right here, or this hole on the board, is marked the ground. And so we're going to ground the chassis through this standoff. So make sure if you use metal standoffs, and that this is going to be our ground to the chassis for the board, is using this terminal right here. And don't know if that's going to be ideal. We may end up having to come in here and chase hum and figure out another way of grounding it and that sort of thing. But to start with, that's what we're going to do. And guys, I have no idea what this thing's going to work like or sound like. So do not copy this until you see the next video and make sure this thing works like I hope it will. Okay, so before I put this thing in the chassis and bolted it all up, I decided to fire it up on the bench while I could still have these wires loose and be able to check all these voltages. And given that I've never worked with this board before, just wanted to make sure that these main voltages that are printed on the board hit their target voltages. So powered the thing up, and it took a long time before the voltages even started stabilizing. But then once they did, this voltage over here that's supposed to be 245 volts was like almost 280 volts. And this is supposed to be 280 volts here, and it was like 340. And I was like, what is going on? So I measured the AC input voltage, and it was like 280, which is like 5 volts higher than it should be. But this volts over here was like 60 volts higher than it's supposed to be. And like all the voltages were whacked out. And like from one side to the other, they were different. And like this is supposed to be 50 volts here, and it was like 75. And I was just, what is going on? So I was looking at the schematic, and these were 3.3K. And so I swapped out a couple of these for 5.1Ks to lower the B plus down a little bit, and it really didn't come down much. And I'm still scratching my head like, what is going on? So I decided to measure the heater voltage, and that's across this rail right here between these two terminals, and it was only 3.5 volts. And I'm like, that doesn't make sense. And like, these tubes aren't drawing a ton of amps, and like, I don't know what's going on. So I started looking around, checking voltage, and then right at this point here, right off of the bridge rectifier, it's got 7.5 volts or 7.3 volts, something like that, which is what I would expect to see coming out of a bridge rectified 6.3 volts, or it's really like about 6.5 volts. So anyway, so then I started looking at the resistors here that are in series on the heater rails, and the board says to put a 3.9 ohm resistor here, and then a 2.2 ohm resistor here. And then you look at the schematic, and I've marked in purple these resistors I'm talking about, and the schematic says they're supposed to be 2.2 ohms. But I measured across these resistors, and there was like almost 2 volts a drop across each of these resistors. It's like, that just doesn't seem right. And then I thought about my EAR clone boards, and they've got less than a half a ohm resistance in the RC filter for the DC heaters. So I looked through my stash and I didn't want to just jump to a super low ohm resistor here and fry the heaters in the tubes. So I put a half ohm resistor in place of these higher value. It was a almost 4 ohms, and then 2.2 ohms. I replaced them both with half ohm resistors. Then I got 5.6 volts on the heaters. And then when I started checking all the other voltages, they were all coming in line of what they're supposed to be. So I replaced these with a couple of 0.22 ohm resistors, and now I got 6.36 volts across the heater rails, which is right where it's supposed to be. And then when I went over here and started checking all these other voltages, they all were spot on. We got right at 1.5 volts here. We got like 242 volts here instead of 245. This is like 151 instead of 150. I mean, everything is within a volt of what the board's printed. And these cathode voltages, like these 1.5 volts, they're all like 1.52 or 1.51. They're right there where they're supposed to be. And then this one here is now 50 volts, exactly like what the board says. So it was starving the heaters, and that's what was causing this issue. So then I started looking at the schematic, and it's like it shows a 2.2 ohm when the correct value is 0.22. Somebody moved the decimal point over when they were copying the schematic, and then they printed it on the board, and then they ship it with resistors that were off by that same amount. There's no way this board would ever work right with the components values that they have printed on the thing or in the schematic. So anyway, I just wanted to clear that up, that when you build these, get some 0.22 ohm resistors, some 3 waters to put here, and then this 5.1K in these 2 locations ends up with, like I said, 242 volts right here where it says 245, and all the other voltages are perfect. And I think the AC is a little hot going in, so putting a little more resistance in the B plus circuit compensates for that. So if you're using the Hammond transformer, that's the way to go. And I will print up a corrected schematic and upload it to my website. Anyway, just wanted to clear that up, and I'm ready to put this thing together now and see what it's going to sound like. So you can see, fairly simple build. Fab work's not too hard. You got the 2 poles in the top. You got 5 bolts that hold the board down. You got a place for the transformer, and then the power switch. And then on the front, you're going to have the RCA jacks IEC connector. So fairly easy to put together a little chassis for it. I'm so sure this is going to work and sound good that I'm going to go ahead and just build it like a finished version. And I know a lot of people breadboard stuff, but that's not my jam. I try to find stuff that I'm pretty sure is going to work and then go for it. And really the only time I've been burned doing that was at 6C33C. And hey, it is what it is. You can't win them all. So I think I've got a pretty good track record of creating winners, and I think this is going to be one. So let me get this thing put together. The next video, I will go over like what this thing sounds like. The step-up transformer that I'm probably going to be using with this may not need it with this board. I did with the Earnhardt Audio preamp, but maybe this one has enough gain to not need it. I don't know. But we'll find out here in a little bit. But I wanted to do these segments that kind of show you this board before I got this thing all put together, because I didn't want to have to take it apart to show you. So anyway, if you're enjoying this content, please subscribe to the channel. Please like the video. Thanks to all you Patreon supporters. Thanks for you folks that are members of the channel. And just appreciate everyone who supports Skunky Designs, either buying stuff, watching videos, making donations at the website. All that stuff really helps keep me doing projects like this. So until the next video, have a nice day.